Hello dear student. So let us start our today's session with this op-amp IC741. Today we will be going to elaborating the ideal and practical parameter of an operational amplifier. Okay. Now the first one property is there. The first one property is the input offset current. So what is meant by the input offset current? This is the operational amplifier circuit symbol. It is the negative terminal, it is the positive terminal. Pin number 2 is there, pin number 3 is there. Here we require the pin number 7, 4, pin number 7 is required plus VCC, and pin number 4 is required minus VCC, and pin number 6 is the output. Okay. Input offset current means the difference between the current in such way that your output voltage is equal to 0. This is known as the input offset current. That means it is the I1 current and I2 current. The difference in way such that our output voltage is get 0. This is known as the input offset current. Next one property is the input bias current. The average of the current apply between the two input terminal of an op-amp in such way that your output voltage is equal to 0. This is known as the input bias current. This is the second one property. Input offset current and input bias current. Next one, it is the input offset current drift. The change in current with respect to the temperature. This is known as input offset current drift. Input offset current drift. The change in input current with respect to the temperature. Now the next one property is the input offset voltage. What do you mean by the input offset voltage? Here already we discussed. This is the pin number 2 is the negative, pin number 3 is the positive, it is a 2, 3, 7, 4, and this is a 6 plus VCC and minus VCC. Here input offset voltage. Input offset means what? The difference between the two voltages V1 and V2 is applied in such way that our output voltage is equal to 0. This is known as the input offset voltage. Now the next one, the input offset voltage drift. The change in input offset voltage with respect to the temperature, this is known as the input offset voltage drift. Next one property, the input resistance. The effective resistance between the two input terminal when operating in open loop mode. That means there is no any kind of the feedback. The effective resistance between the two input terminal is known as the input resistance. The input resistance is ideally infinite. Now the next one characteristic, the input resistance. This is already we have seen. Okay, next one, the output offset voltage. The output voltage when the two input terminals are connected to the ground, that is known as the output offset voltage. When the two input terminal, that is the pin number 2 and pin number 3, both are connected to the ground, both are connected to the ground. Okay, then how much amount of the voltage is generated to the output side? This is known as the output offset voltage. Next one property, the bandwidth. The maximum frequency over which the output voltage can be swing. This is known as the bandwidth. Ideally, the operational amplifier bandwidth is the infinite and practically is the 2 megahertz. 1 or 2 megahertz. Okay. Next one, output resistance. The effective resistance when in the open loop mode. This is known as the output resistance. Output resistance is ideally 0. Practically is the 75 ohm. Next one property is the power supply rejection ratio, PSRR, power supply rejection ratio. Okay, so what is meant by the power supply rejection ratio? The change in input offset voltage to the change in supply voltage. This is known as the power supply rejection ratio. A power supply rejection ratio is ideally required 0. Ideally required 0. Then next one parameter is the CMRR. CMRR stand for the common mode rejection ratio. So what is meant by the common mode rejection ratio? It is differential mode gain to the common mode gain. It is AD divided by AC. So this is known as the CMRR. CMRR, it is ideally required infinite. We amplify only the DC signal. AC signal is a 0. So that's why anything is divided by 0. It is the infinite. Ideally the CMRR is the infinite. Next one, slew rate. What is meant by the slew rate? The change in output voltage with respect to the time. This is known as the slew rate. Ideally, the slew rate is required less as minimum, but practically the value is 5 volt per microsecond. Okay, so this is the table actually. Here, voltage gain of ideally op amp is the infinite, but practically it is the 2 into 10 raised to 5. Bandwidth is the infinite. Practically it is the 1 megahertz. Input resistance already ideally we have seen it is infinite, but practically it is the 2 mega ohm. Output resistance is 0, but it is the 75 ohm. Practically CMRR it is the 90 dB, and ideally it is the infinite. PSRR ideally required 0, practically it is 150 microvolt per volt. Okay, input offset voltage ideally required 0, but it is the 6 millivolt. Input offset current is required 0, but it is the 200 nanoampere. Slew rate is ideally required 0, but practically it is the 0.5 volt per microsecond. Already we have seen the input to the output phase shift. It is the 0 to 180, and practically is also 0 to 180. On with the next one lecture, we will be elaborating the topic that is the virtual ground. Thank you so much, student. Stay tuned.